Okay, everyone, we'll go ahead and get started. Well, welcome back to the intermediate pipeline. If you are new here today, welcome. Like I said before, all of our materials will be posted in the Slack, so make sure to join that for frequent updates about the pipeline. This week, we're going to go over a little bit about visualization in Python. This week, it's going to be mostly Altair. We'll do a little bit of coding with Matplot and plotting in Pandas next week. So for those of you who may have missed it, and just as a general recap, last time we went over sort of a general overview of what a data science pipeline looks like, what the goals of machine learning are specifically, and then also different types of machine learning that exist, supervised versus unsupervised learning. Just a basic overview of concepts that we'll eventually get to later down the line. So in general, we can say that the data visualization step, which is essentially creating some sort of materials to reflect the nature of the data in a more intuitive way. This can happen at the beginning of the process. Maybe you've acquired a data set that you're interested in, and you've done whatever cleaning you need of it. And now you're trying to see if you can discern your next steps through visualization. This really is not a solid step in the process. It's not super linear or anything. You can really use visualization to create figures pretty much anywhere along the process. It's more for your own clarity. Maybe you can do this at the end of your project as well, if you have results you want to convey, or if you're creating some sort of report. You can really use it anywhere. So it's just something that's a useful skill overall, and that's why we go over it so early on. The why for visualization is actually fairly straightforward. If you look at the 4 plots that we have here on the right, you'll notice that these are all very different pictures, but each of these data sets actually has the same mean and variance, which in itself is a little bit deceptive because these are all very clearly different plots, right? The algorithm for each of these actually creates this regression line that's the same for all of them, though. So interpreting figures is something that is really a skill that we have to learn how to do, because it's a lot of the time very deceptive to make inferences just based off of pictures alone, right? So like I said, visuals can be very misleading. Scaling is one aspect of any figure that we have to take into account when creating a graph that has integrity, right? I'm sure we've all seen examples of bad visualizations. I'm going to show you a few right now. This is one very good example of a bad visualization, just because you can sort of get this weird interpretation of scale, even when there may not actually be much variation between each of these calendar years. So just looking at it, as it is, you might think there's a lot more change actually happening than may be true. So other examples of really bad visualizations are things where there's just a lot of detail, but no clear scaling or anything like that. If you look at the one shown here, you really can't get a sense for what is going on at all. Is this showing like proportions of diseases as compared to a whole? Is it showing the most common diseases for a certain demographic? You really can't get a sense for what is going on easily by looking at this. Too many features. If you try to include every feature that you observe in your data set, well, a lot of the time it's going to be hardly interpretable in a case like this, especially. And in some other cases, it's just wrong, and the math is not right at all. This is an example we had from last week for anyone who wasn't here to see this, but creating visualizations for trends is one way that we as humans can get a better sense of what is going on when otherwise we wouldn't be able to tell through looking at, rows and columns alone. And this is something we don't necessarily have to do by hand. We have plenty of algorithms that can compute these things for us. It really just makes it easier for us as humans to interpret the data at hand. So 3 things I want you to take away from this. If there's anything important about visualization that I want you to remember, it's this, that visualization can, 1, help us deal with outliers and figure out what outlying points there are in our data set, if there are any. This can possibly indicate like imputation errors or something like that, or it could just be something that's naturally occurring as a result of noise in our data set. It can also help us with things like model parameter selection, feature selection, things that help us tune our model to make it more accurate in the model building process. We'll talk about Altair today, which is sort of a general plotting tool in Python, but there are also some very domain-specific visualization tools that you may use in the future if you're interested in any of these subjects. If you're interested in things like neuroscience, I know there's a couple different tools for that that could be used. Another really common one, especially at UCSB, with a lot of our more geographically oriented labs here. A lot of them use GIS, which is software for more geography-based modeling. And if you ever go into, if you go to work at some sort of corporation or anything that involves business analytics, odds are you'll probably be using Tableau. It's just another thing that is particularly common. So when I talk about features in a data set, what I'm referring to is the type or the classification of a specific feature. You'll notice that with our Titanic data set, which we visited last time, we have a pretty clear outline of different features that belong to each of these passengers. Some of these features are different from one another. You'll notice that there's some features like age, which are completely nominal. They have a number associated with them. The number value speaks to its meaning. There are things like ordinal, in this case, we have class for each passenger, which is an example of an ordinal feature where the order of the class is important, first, second, third in this case. And then we have quantitative features, which I'm sure you're familiar with. These are descriptive features. So like the color of something, the size of an object, usually expressed not as a number, but oftentimes as a categorical variable, or like a word or in some language. Different types of visualizations we're going to be using. Most commonly, we've all seen these before. Bar charts are to be used in cases where you want to know how many items or how many instances of an item belong to each group. So say you have like a fruits data set, you have different types of fruits. Maybe column A is listed as like apples, B is like bananas or something. This would be a good way to visualize how much in terms of quantity belongs to each of these specific groups. Histograms are also another common one. This is most useful for distributions where data sets where there is a clear distribution. So say something is like normally distributed, you're going to create a histogram based on a data set that represents the grades you received for a single class on a particular test or like midterm or something, that you can usually expect to have some sort of distribution associated with it. And by plotting it in terms of histograms, you can get an idea if there is a defined distribution. Box plots are another one. This sort of gives you a general summary of these sort of base statistics like median, mean. If there are any outliers in your data set, that's something that's very easy to see through a visualization like this one. And then line graphs are most useful for like time series data sets, things where there's some sort of trend or change over time that you want to show, that's when you would most commonly use a line graph. So like, as you can see here, sales over time would be reflected, in this case, on a monthly basis. And you can see the fluctuations in quantity from there as well. Correlation heat maps are another one that's, I know you can use Seaborn, which is another Python package for visualization. But the thing I will say about correlation heat maps is sometimes they're a little difficult to interpret. Like I said before, the purpose of creating these figures is to, make your data set a little more easily understood. In this case, this correlation heat map might not be as easily scrutable, just since you'll notice that our values are just codes and we don't really know what that means exactly. I think a better example of a heat map that would be useful would be in a case like this. So this is obviously comes from a data set based on real estate. And in this case, you see using color, we can show correlation between different features of the data. So like, for example, you'll see that maybe total square footage of a house more closely correlates with the overall quality. So like nicer places tend to be larger, or larger places tend to be nicer, be more expensive. Same goes for negative correlation as well. Another good example of a heat map that isn't necessarily a correlation heat map, but just a regular heat map, is when you're using data that's spatially distributed. So like segmented by geography, right? So something like this, if you were looking at like COVID transmission by county, and you wanted to show greater risk of transmission as opposed to decreased risk of transmission, you could do that on a color scale as well and do it something spatially like this. So I think in general, that's what I would say is probably more useful application of a heat map. Like I said, you have all the slides. These links will be available to you. If you want to peruse the entirety of the documentation, feel free to do so. The links will take you there. The top one is for Altair, which is one package that we'll be using in this week's notebook. We'll also be going over Matplot a little more next week. Feel free to take a look at it now. But in summary, there are a lot of packages we can use to visualize. There's really, endless number of possibilities. But like I said before, Seaborn is another one that you might encounter, especially if you take classes here at UCSB. ggplot actually comes over from R. So if you have any R experience, that is also something you can use in Python. So quick note on Altair, which is, like I said, a visualization package for Python. It was actually created by this guy named Jake Vanderplas. If you've taken any PSTAC classes here at UCSB, you'll know that often professors will like to use this textbook, which he actually wrote. He's I want to say a software engineer at Google, who created Altair, or at the very least worked on it. These links that I have here on the slide will actually take you to the textbook itself, which is completely free online for anyone to use. It's a great resource for Python and data science. So if you ever are working on something, if you're doing a project down the line and there's a concept that you don't exactly remember how to do, this is a great thing to consult, because there are code examples in here as well. So there's sections on all sorts of things, visualization and Matplot being one of them. And this is just the documentation for it. This textbook is essentially like a GitHub pages, which is like a website that's made through GitHub. So if you want to see the documentation for that, all the code and stuff, it's all here for you to use. These are just some of the basics of using Altair for your reference. Every time we plot, we're going to start with passing in our data frame or whatever it is that we're using as our data. In this case, it's a pandas data frame, which you should all probably be familiar with, into our chart function. And these are just, this is sort of a snippet of the documentation that shows just a few different plot types that you can use. And ultimately, whichever plot you do use is up to you. It depends on the type of data you're using as well. And there are examples for all of them in the documentation as well. The simple structure after we pass in our data frame is relatively simple. We've chosen the type of graph that we're going to create, and the rest of our parameters sort of depend on sort of your customization in a way. Obviously, we can have different encodings for things like color. We can pass in different arguments after the fact to create essentially what we're going to put on our different axes. Right? Like I said, you'll take a look at the notebook for this week, and we'll go over it a little bit next week as well. We'll go over what kinds of encodings you can use for the Titanic data set in particular. Tasks I have for you for this week, if you weren't here last week, take a look at the tasks I assigned you all from last week. It was relatively simple. I think I told you all to like make a GitHub account and like get familiar with a Python editor of your choice, which is usually either Google Colab or Jupyter Notebook, whichever you happen to have. This week shouldn't take you too long, it's just a few things. Like I said, you have the slides to take a look at this and reference throughout the week. But the only thing I definitely for sure want you to do is go to the Get Started on Personal Projects workshop, which is this Thursday at 7 p.m. Go to that for sure. It will benefit all of you. I'm sure you will all wanted to go regardless. So definitely attend that one. It's essentially a more condensed version of all the topics I touch on in this pipeline. So if you're thinking about getting started on a personal project before the quarter is out, definitely go to the workshop and do that as well. Okay, like I said last week, I will stick around for a few minutes after I finish talking and going through the slides and all that, just in case you have any questions. Can really be about anything, projects, the club itself, you know, questions about the club, or even like classes at UCSB, really anything you're curious about. Notebook is, I can actually put the link in here, but it is also in the Slack. So in our Slack channel, so. I'll give the link to you. But that's all I have for you guys this week. Definitely go through all the items that I listed for you at the end of the slides. All the links for this week are also at the end of the slides, so that's there as well. But yeah, like I said, any questions, I'll stick around and see you guys all next week.